Hello, everybody, and welcome to the final session for our first day of the Big Mountain Data and Dev Conference. I'm Madeline, and I'm going to be moderating today. This is room 5. We've got Dan Stober here with us, who's going to be talking about D3, what I learned during the quarantine. So, Dan, without any further ado, you are more than welcome to take it away.
Thank you, Madeline, and welcome everybody, and thank you for choosing to come and sit through my presentation. I hope to share some information with you and get you as excited about it as I was. This is the abstract of the course right here. I won't read the whole thing, but I'll just tell you that in brief, we're starting at square zero. So we assume basically no knowledge at all of D3. And by the end of this session, we will build a simple chart, but give you some guidance on how you could go much further than that. So who am I? There's my picture. I guess my picture is covering my picture, but I've been doing databases, data architecture, visualizations, all that kind of stuff since 2001, mostly at Intermountain Healthcare. I currently work at Select Health. I did spend a couple of years working at a consultant as well, where I had a chance to use lots of other visualization tools, and it got me more interested in playing with some of these things right here. I've also been a presenter through the years at a lot of Oracle user groups here in Utah, and even a couple of times at national Oracle users groups as well, including at Open World. My most recent presentations, right before the shutdown all happened back in February, I presented at a Tableau user group here in Draper. And then I presented at the Big Mountain Data Conference. I missed last year, but a couple of years ago, I taught regular expressions. So my style, if you haven't seen me present before, is I tend to try to put everything into the slides so that you have a self-contained thing, a reference to go back and look at. So you don't have to scribble and take a lot of notes or try to remember what I did, is because I try to get it all in there so that you can see it. So I have a PowerPoint, but I also have live code, and we'll bounce back and forth. And I know sometimes that's a little jarring when we go back and forth, but bear with me because I try to keep it all complete. I like the idea of having everything self-contained though, because when it gets put on the web, and I've had people contact me years later and say, hey, you know that presentation you did about analytic SQL, I found it on Google and it helped me answer my question. So I love it when I get stuff like that. And so that's why I go to the trouble of putting all the stuff into slides. So here's what we're going to talk about today. We're going to talk about what is D3, why I find it interesting, and why I hope you'll find it interesting as well. And then we'll just start the building blocks to build the chart that you see on the right. Now, again, it's not a flashy chart, but there's a lot of different pieces that we have to do to make it work. So we'll talk about SVG and shapes and how we define those. And then we'll talk about how we bind the data to the shapes in SVG. Then we'll talk about scales and then colors, and then how we got the labels on there. And then I'll show you a further example on how you can take what we're going to be able to build today and make it flashier and make it something that's really cool. Okay, so we'll start here with what is D3, and basically the 3Ds are data-driven documents. You may also hear it referred to as D3.js. That's because JavaScript is a very important component of how the whole thing works. And so if you're searching for documentation and that kind of stuff, you might want to search both ways because you'll find different pieces of documentation listed those ways. Basically, it's a charting library. So it's a JavaScript library that uses SVG and then JavaScript to manipulate those items on the SVG canvas to basically create a visualization. It was developed by Mike Bostock, who works for the New York Times and has a couple of different websites. And in just a second, I'm going to show them to you. And it'll probably, again, get you excited about some of the things that you can do. And again, it binds the data elements to the display elements which then allows you to animate it. And again, you've probably seen some of my Mike Bostock's work at various things that that we have. So why do I like D3? Well, as I mentioned, I spent a couple of years working in a consultancy firm, and I kept on bumping up against various things that the charting tools that we were using just couldn't do. And you know, we weren't using bargain basement. These are names that you'd know, but they all have their limitations. And sometimes it was super frustrating that we couldn't do things that seemed like they should be fairly obvious. But once you do the research and then you find the gurus on YouTube or, you know, in the blogs have written super complicated code to do things that seem, like I said, something that should be able to be accomplished. The other thing I like about D3 is that it's open source, which means you don't have to install anything. You don't have to get a license key. You don't have to, you know, give your email address to anybody. There's no barrier to entry whatsoever. Simply, if you have a web browser and a text editor, which every single one of us has on our computers, you can get started. And the potential, again, is unlimited. So in the lower left-hand corner here, where I have examples here, these are the two websites where you can grab plenty of different charts to get started on your own. So I'm going to do the first of my promised bounce outs here from the slides and just show you right here what kind of things they have out here for you to look at. And let's see, like for example, if you wanted just to do a basic bar chart, like we're going to be doing, this one has a rollover, and it also has you know, the ability to put line breaks in the labels and stuff like that. So there's an example on how to do that. There's also plenty of animated ones, as if we look at the ones on Observable here. For example, here's an animated one that he calls the bar chart race, and it essentially takes 20 or 30 years worth of data on the size of companies. And over time, you can see it counting down here below 2002, 2003. The size of the bars change and the positions change as well. Again, this is all just done with the basic D3 charting library here. So there are in these examples here, sorry, I'm not able to get back to, there we go. There are just hundreds of things that you can use to start with, and you can fork them off GitHub and use the work that someone else did to get started if you want, and develop them to fit your own data and make some really impressive things. So I actually have my own website as well, where I've put some of my examples. Mine aren't as impressive as Mike Bostock's are, but for example, this is the only one that I've ever put in production, is this one right here. And we had been working with a retailer company, and we didn't have all of the data that we thought we did. And so I was looking for ways to try to quantify to my bosses and our partners exactly, you know, how much data we had and the quality of the data. And so I put this together to show based on the number of retailers that were participating and based on the dollar volume, to show just how inconsistent the data that we had was. And then I created another one down here that really went through week by week for all of the years, going back 3 years, and each reporting entity to show whether we had data from them or not, just so they could see how scattered it was. And this wasn't particularly difficult to build inside of D3, and it really drove home the point that I was trying to show them. So I have this up here in my gallery. That's the one that's labeled as POS files, and a couple of other examples here. I have this one. Most of the stuff I do just on my own. A scatter chart where I'm comparing the opening dates of Tioga Pass with what the snowfall is, so the more snowfall, the later in the year it is, as well as a Gantt chart that shows year by year when it opened. Another example I have here, this is actually the one that I'm showing you here, is an extension of what we're going to build. So we're going to build basically a bar chart that shows the finals for the 2018 baseball season, but you can see I've added animations to it and additional years. And so you'll be able to see how to do that as well, starting with the code that I've already created. And then just one more, my data set of how many trick-or-treaters I get each year. Since Halloween is next week, so I'll be able to increase this chart as well. So anyway, I have my own charts on here as well, and you're welcome to look through these. The most important thing though is that I've created the charts that we're going to be building here. I've created a page that has each one of them at various points, so you can go and see as we're building it the code frozen in time at that particular spot. So you can go and grab these as well, and you can pull these out to look at the code behind that as well. Okay, moving ahead here. As I said, D3 is open source and there's no additional things that you need, but there are basically 3 different components when you start talking about developing things on the web. You have HTML, you have CSS or cascading style sheets, and then you have JavaScript. And you're going to have to get yourself involved in some portion of all of these in order to learn D3. So unfortunately, that's one of the downsides of D3, is there is a little bit of a learning curve to get up to speed. Now, if you're comfortable with all of these, that will hasten your ability. But if you maybe aren't so good with CSS, or your JavaScript is lacking, you'll probably have to spend some time coming up to speed on what to do. Now, in normal production environments, often these 3 components are in 3 separate files, kind of the idea of separating the content from the presentation and from the scripts. In my case, I've put them all into single HTML files just to make it easier to transfer the knowledge, because you only have to download 1 file instead of having to go and download all 3. So let's get started with what is SVG, and it stands for Scalable Vector Graphics, and it's just basically a way to use HTML tags to create images on the screen. And D3 makes use of shapes in SVG to create the visualizations that it creates. And so when you think about it, most charts that you look at are a combination of rectangles and circles and lines put together in some format in order to convey the message that's trying to be created. So again, that's how D3 works. It's going to basically pile on and use SVG to do that. So let's get started now by talking a little bit about how SVG works. And essentially, you're going to create a canvas, and then we're going to plot our shapes onto that canvas. And so the plots are made using X and Y coordinates. And the X values go from left to right, okay, from 0 up into the width of the canvas. And then the Y values go from top to bottom, with 0 being at the top and height being at the bottom. And I made a note here in yellow that orientation of the Y-axis will trip you up when you start to, especially when you want to make horizontal bar charts. And I'll show you more what that means in a couple of minutes here. But essentially, the challenge is that the numbers get higher as you go from top to bottom along the Y-axis. But typically, you'd like the numbers to go from bottom to top when you're building a chart, where the lower numbers are at the bottom and the higher numbers are at the top. So it's just an additional consideration that you have to work around to relate the layout of the SVG canvas to the layout of the way your shapes are going to be. Okay, so with that in mind, the first step to creating anything is to link to the D3 source code. These are the libraries that you need to do S3. And so right in the head of your HTML page, you're going to insert this line right here, the script tag with the source and that particular thing right here. Now, I'm pointing out that this is version 5 of D3, and all of the examples that I have built are in version 5. However, I will note that version 6 is the latest version, and 6.2 actually came out last month. For the most part, it works the same, but here's where it behooves you to pay attention. In many of those examples that I showed you on blocks.org and on the observable web page, for example, when you go to get the code, you have to pay attention to which version of the JavaScript library that it is, because there are things that change over time. And one of the things that caused me to pull my hair out when I was first starting was that I would take the examples off of those pages and paste it into my page, and then I would get errors because certain things had changed over time. And the one that comes to mind right away is the way that scales are done. So I'll try to remember to talk about that again when I get to it. But just keep that in mind that some of the examples could be in older versions. So always take a peek and see which version of D3 the code is in when you start to grab it off of the web. Okay, so now that I told you where to go get the code, I've now expanded the code. And by the way, I apologize a little bit because I know that slides that contain a lot of code can get unwieldy and even start to look a little bit crowded. And so I try to do a lot of work to balance it out. I know that in some cases it's going to be overwhelming because I like to call out things again so that it's a self-contained presentation on the back end when someone is looking at it later and they don't have me interpreting it for them. So just kind of bear with me. So this is all in the head section of the HTML page. And again, we see the call for the script. And then we see a JavaScript function itself. And then in this particular case, all I'm doing is I'm rendering the SVG canvas. And we'll talk more about this particular section on the next slide. Okay, and then at the bottom, I have a style where I have creating a cascading style sheet. And the only thing I'm doing here is I'm applying a color to the back of the SVG. And it just helps me when I'm developing because then I can see the size of it as I'm working and see if things are going where it ordinarily would be. Otherwise, it'll just look white like the rest of the web page, and it's difficult to see the canvas itself. So this style section right here isn't required, but I usually throw it in there at least while I'm developing so I can kind of see what I'm doing. Okay, and then here's the body of the web page, and you see that when the page loads, it calls my render function, and then I have a div tag with an ID, and so that's essentially where the SVG is going to be rendered. It's going to be inserted into the DOM as a child of this div tag right here. So let's take a look at this particular section of the code that's actually inserting the SVG into the div tag, and we can see some pieces of the D3 API that we'll see an awful lot. So let's talk about each one of these. We have an append, and all append does is it's saying that for whatever part of the DOM or document object model that you're currently referencing, you're going to insert a child element under it. Okay, so in this case, I've selected the div tag and I'm appending an S3 under it, or basically between it as the page is rendered. And then we see the ATTR attribute, okay, and it's done in the format of the name of an attribute and then the value that's to be supplied to that attribute. So like a name value pair. And we will use this a ton as we put all of the shapes onto the page. And so you'll see more and more of these as we continue along. And then the select was how D3 knew that I wanted to select that particular div that I had on the page. And this just uses CSS selector notation. So since my div tag had an ID of chart here, then the pound sign is the way that you reference an ID in CSS selectors. And so basically, if I had more than one div tag on the page, this is the way that I'm telling it that that's the particular div tag that I wanted to have selected. Okay. The last thing that I want to call out here is that this API call can return a value. In fact, it always returns a value, but we don't necessarily have to assign it to anything. But in this case, it's going to return a pointer or an object reference to the SVG that was created by this append. Okay, and so I'm assigning that to a variable. Now I named the variable SVG. I didn't have to do that. It's a variable, a JavaScript variable. I could have named it anything at all that I wanted to. But by convention, most of the code that you'll see, people assign it to a variable named SVG. So there's nothing magic about that, but it just makes it easier to read other people's codes when you follow the conventions. So I'm assigning it to a variable named SVG, and in the subsequent calls that you'll see that I'm going to be appending things to this SVG, and that's how I'm going to insert all of the shapes that we're going to do into this SVG. Okay, so now we're going to get into SVG shapes and how we define them. Okay, so again, we had a canvas, and the canvas that I created was 800 pixels wide, 400 pixels tall, and so that's the canvas that you see right there. So if I'm going to insert a rectangle into it, I have to provide some information so that the web browser knows where to draw the shape that I'm going to insert. Now, maybe when you took geometry back in 9th grade, you defined rectangles maybe by supplying the X and Y coordinates of the 4 points. But in this case, that's not the way it works. What we do is we define the X and Y positions of the left and top corners or sides of the rectangle, and then we derive the other two sides by supplying the height and the width. So, from that we could derive what the points are for each of the 4 corners. But again, the way that we do it is by saying what is the X, what is the Y, what is the height, and what is the width. And that's how we go about defining a rectangle within D3. So you see this first one, I've defined a rectangle that has an X of 75 and a Y of 175 and a width of 350 and a height of 50. On the other hand, in this case, I'm defining a vertical bar. And in this case, the X is 650 because it's way across. Oops, it's way across. And the Y is only 75 because it stretches up near the top. And the width is 50 and the height is 250. So again, the idea here is, one more thing to state about this too, is that you can see that if I'm doing a chart where the bars are horizontal, that my data value is going to be captured by using the width. So if I look at the green one there, if I had several of those green ones, right, ordinarily they would be different lengths. And so you do that by changing the width on those. If on the other hand, I have a bar chart where the bars are horizontal, now I have to map the data instead to the height of it, because that's the side of the rectangle that I would like to change as the data values change. So this is how we go about drawing rectangles inside of it. So I kind of showed you the X and Y and width and stuff on the last slide, but this is the actual code that we would insert. So we see at the beginning of each one of those, we have SVG append. And remember, SVG is just the variable that is the object reference for the SVG that I created in the earlier slides, right? And if I had named it something else, then I would put something else here. But again, the convention is that we use SVG. So that's what I did. And so I have SVG dot append. And so I'm appending a rectangle, and then you see the same coordinates, the x75, the y175, et cetera, et cetera. And I also supplied a fill value, and the fill value is a color, and it could be, using hex values with a pound sign, like old school web coding does, or you can use some of the named values as well. So in this case, I chose lime green. The second one, again, those coordinates are the same as well, and I chose turquoise for that one. If you're an astute follower of the code, you may also notice that in the upper one, I use double quotes around the items, and in the lower one, I use single quotes around them. JavaScript allows you to use either double quotes or single quotes. The only thing that you have to do is you have to make sure that you close with whatever one you opened with. But other than that, they're interchangeable. And I hadn't really noticed it too much, but I guess I had kind of developed a bad habit, because as I was putting these slides together, I realized that I wasn't really consistent in which one I used. So I tried to clean them up some as I was putting this together, but don't think too poorly of me if I missed one somewhere along the way. All right, here we go. So these are the attributes that go along, right? So aside from the X and Y and width and height, and by the way, I think I forgot to call it out on the last page, but notice each one of these is .attr. So this is just additional attributes. And, we write them on separate lines, but really you can think of it as they're all chained together as being attributes that are for this rectangle that's right here. And as many attributes as we needed to supply, we can put as many as we need to here. There are some other attributes besides the 4 that are required, besides the X and Y and width and height. And the most common one is fill. And again, I said that's the color. If we didn't supply a color, they would be black. And we'll see that in a second. The other way that we can address the color is by using the CSS style. And so you see down below, I'm addressing a couple of the other attributes that could be part of a rectangle. The stroke refers to the line around the outside of it, and the stroke width then refers to how wide the stroke is around the outside of it. Okay, so as I create the elements, one thing that I'd also like to call out is that, you can always go and you can look at the DOM inside of your browser. And all of the major browsers support this. I've looked at all of these examples in Google Chrome, I've looked at it in Firefox, and I've looked at it in Microsoft Edge. And you can do it in all of these to kind of see if it's not rendering the way you expected it to. It's always useful to go in and take a look at it. So I have this example right here. In the example page I showed you, you're welcome to go and pull this up, and you can look at these examples and change them. You can download it and change them and try to experiment with it and see how it works. Okay, if instead we wanted to do circles, we can do circles as well. Notice that the attributes for circles are no longer X and Y. It's actually CX and CY, which refers to the X and Y points of the center of the circle. And then R for radius. And again, those are the only 3 attributes that are required. If you don't supply a fill, it would be black in the middle of it. I will call out this CX and CY because it's a mistake that I've made several times, where I've tried to code a circle and I used X instead of CX, and then it didn't show up on the page, and it took me a while. So it's a rookie mistake, right? But we all make lots of those as we're trying to learn different things. So it's kind of a gotcha that is probably going to catch you at some point when you first start coding these things. Okay, so these are the basic attributes for the basic things that we would put on a chart. And again, There are more SVG elements that are possible, and you can check the documentation for more of these. But basically, for a rectangle, you see those. For a circle, you see those. If you have a line, you supply x1 and y1 and x2 and y2 as basically the endpoints of the line. And then as well, you supply the stroke for the color of the line and the width for how wide you want the line to be. And then the fourth of the basic elements that we can put on an SVG is text. And we'll use that for labels. And so those are the things that you would put there. I put an asterisk next to the word text under the text element because that's the one that we don't actually supply using the ATTR attribute code. We actually do that by just using .txt, or sorry, text when we supply it. Okay, so we've gotten the basics of how to create an SVG and how to put shapes onto an SVG. So now we're ready to try to put some data into it and begin to actually build a chart. So you see here, I have a couple of new things that we haven't seen before. Most of this stuff you should recognize. We have the append rec and we have the attributes that are going with it here. But we have this new thing called select all. And then we have this data right here. So select all basically just means if there's any rectangles on the page already, then map this data to them. And it's used for more when we get into data sets that are animated. And sometimes you have more points or fewer points than what you already had rendered. And so you need additional ones to appear or disappear. In this particular case, there are 0 rectangles on the SVG after we've created it. So when it does select all, there are none to be mapped to. So it will take this data set and it will append a new rectangle for each item that's in this data set. So in this data, we have 5 different values, 106 through 71, okay? And it says, oh, well, when we have a new data set and we don't have an existing rectangle, then it calls enter and then it appends it. So we could spend a lot of time trying to talk about what enter and exit do, but just trust me on this at this point, and at this level, just know you need to put the select all and rect, and then the data, and then the enter. And then after that, you will get appended 1 rectangle for each element that's in your data set. Okay, so let's take a look now at this code right here, and let's see what happens. So I have this, and well, I expected to get 5 rectangles, but I'm only seeing 1 rectangle. So this is now where I turn to inspect the DOM to try to see if I can understand what went wrong. So when I pull up the DOM right here, I actually can see, oh, wait a minute, there are 5 rectangles. But if you take a look, they all have exactly the same X and Y positions and the same width and height. So what's actually happened is it really did create 5 rectangles, but it stacked them all, one right on top of the other. Now, again, this wouldn't be so apparent if you didn't use the inspect to go and take a look at it. But once you do, you say, oh, that makes perfect sense. Okay, so the code is actually doing what I expected it to do, although I just hadn't thought it through all the way. So the next step is going to be that we actually need to, instead of hard coding these X and Y values and this width and this height, we need to find a way to reference this data that's in our set of elements right here and use those to apply to the attributes instead. So that's what we're going to do over the next couple of slides, is we're going to modify this now so that the rectangles can be different lengths depending on the value of data and positioned at different points as well. So I'm going to introduce another concept to you here, which is the inline function. And basically, this is something in D3 that allows the API to access the value from each of the data elements as it iterates through them. and there are two flavors that you'll see here. One of them is function with one parameter, and another one is function with two parameters, okay? And we'll talk about what each one of them does here, but essentially, if you just go function D with one parameter and you return that, then it will return the value from the data set for each iteration. So for example, the first one was 106. So the first time through, this function D would return 106. The second time, I think it was 71, it would return 71. The second one with the second parameter allows us actually to know which iteration we are in as we're looping through it. So as it iterates through the values in there, it tells you that you're on the first one, the second one, third one, etc. Now remember, JavaScript is indexed at 0. So the first one that comes out, the I value would be 0. The second one would be 1, etc., etc., etc. And again, we could use any variables we want here, but the variable names are D and I by convention. And so it's best to stick with those. So let's take a look at this in practice now and see if we can understand more how this works. Okay, so here's my data set, and here's the changes that I made. So let's start with the width one. We see that in width, instead of having 350, I've now inserted the inline function there. And so where it previously had said 350, it now says function D, and then in curly braces, I have return D and then a semicolon. And so with each iteration, it will return the value of that element. And so you can see the first one, that one is 106 pixels wide. The second one is 77 pixels wide. The third one is 85 pixels wide, et cetera, down through the whole data set. The other thing that I did is I positioned them so that they're not lying on top of each other by addressing the Y value in each of these. So you see I'm calling the function, and this time I'm using both parameters, and I'm only addressing the I in the return value. Okay, so I'm saying on the first one, the I is going to be 0, because again, remember JavaScript indexes at 0. So it will return 0 times 60. So the first one, the Y position is 0. The second one, on the second iteration, the value of I is 1. So that's 1 times 60. And this one has a Y positioned at 60. And then on down the line, 120, 180, and 240. And so now I have it so the rectangles aren't lying on top of each other, and I have them all in such a way that, you know, they each are different depending on the data that's in there. And this example is on the website that I showed you, on my own website, and it's example number 1 and then dash NLWest underscore pixels. So you can take this out and play with it as you want. Now, that's all well and good, but you know, these differences in the values of the lines aren't all that extreme, and we're also wasting a whole lot of space because this this SVG canvas is 800 pixels wide, but the highest value is only using 106 of it. So instead of mapping these data elements straight to pixels, it's time now to introduce the concept of a scale to it. Right? And so if the whole canvas is 800 pixels wide, maybe we would want the maximum value to be equivalent to that. And they only play 162 games in a baseball season. And so I'm going to say, okay, if anybody were to have the maximum value, we would make that be 800. If they only win half their games, then we would have it be only halfway across, and et cetera, et cetera. So I can do that mathematically. It's a very linear function, right? And I can figure it out. And so I could change my D function that you see to now return D times the width of the canvas divided by the maximum value. And that would then scale out and have each of them, you know, be more representation as a percentage of the total size of the canvas. That would be how long it would be. Now, maybe that makes sense to you, but there's actually a better way to do it, because D3 provides to us scale functions where we can set up a scale, and it's best to do it this way. First and foremost, because your axes, when we get to the point where we're going to add axes to it, we can reference the scale and then have it use that to build the axis for us. And so we do that simply by saying, well, what's the domain of the data, and what's the range of the canvas? And so in this case, we're saying the domain is somewhere between 0 and 162, and the range is somewhere between 0 and 800. Now, I tell you that more than once I got confused as to which one is which, because, oh, range, is that the range of the data? And so the mnemonic that I came up with is just remember, D is for domain and D is for data. So put your data, the range of the data in the domain, and then the range of the SVG into the other one. The other gotcha, well, there's two more gotchas I want to tell you about here. And the first one is that these values must be entered in square brackets. So it's an array basically with the lowest value and the highest value. And I can't tell you how many times as I was learning this that I created these and I forgot to put it in square brackets, and it just wasn't returning anything. And I was kicking myself trying to figure out what the heck was going wrong. So it's a mistake that you'll probably make at some point. Don't forget to put the square brackets. The other thing, earlier when I was talking about versions changing, so in early versions of D3, the scale function actually went scale dot linear instead of scale linear like this. And so I would have examples where I was pasting out of those observable web pages, and I would paste them into mine, but I was trying to do it in version 5, and I was getting that there was no such attribute or no such function, or errors like that, and I couldn't figure out what was going on. So pay attention to that as well, as that these have changed over time. So here we go now with a linear scale, and so we can see our data set I now have mapped to a variable by itself. Okay, so if we go down and we look in here and we see the data set, we see instead of having the data listed, I just have it listing that variable instead, but it's still the same 5 numbers as before. And then down here in the attribute, you can see that I've showed the width 2 different ways. One, doing it with the linear calculation, and the other one using the X scale variable that I set up here. And I have one of them commented out. And when you go to pull the code for this off of my website, off of the scale page, you'll see that I have it both ways for you. And you can comment out one or the other, and you'll see that it works exactly the same way in either case. Now, again, it's a linear scale. And so you can see the scale that we have set up depending on the value. This X scale is a function, and you can call it and see the values that are returned. But you can see each one of them returns a pixel translation, and that's what's actually being passed to the width for my bars. And so you can see here that I've now created 5 bars, and they're each one a different length to compare to the data. And I know I've got to talk a little bit faster because the time is slipping away really quick. So because this vertical bars isn't integral to the presentation, I'm going to talk quickly through it and just show you what the challenge is here with the vertical bars. Is that I've just flipped everything around between the X and the Y, and it ended up creating a chart that looked like that, which is not exactly what I'd want to do with a vertical bar, because I really want the bars to come from the bottom instead of the top. So when you create vertical bars, the Y value actually has to be a calculation of how far off of the bottom is it, right? So you basically have to use the Y scale a couple of different times in order to get the bars aligned the way you want. So that's an example that's on my webpage as well, and you can look at that if you'd like to play with that and understand it. But let's get back to the horizontal chart now, because I still want to get to the colors and the labels before we wrap up here. Okay, so we've got our charts, and I've mentioned that we can address the colors as an attribute, but we can also address it in CSS. So the challenge becomes, what happens if you have conflicting values in here, right? And so I've specified a fill down here as plum, and I've specified a fill up here as steel blue. Well, the model of CSS is that the style sheet will override the HTML. And so if we did that, this one would generate steel blue bars because the style sheet overrides it. If I want to have something that's specific inside of here, I have a new one that I could put. Instead of using ATTR, I can use style as a part of the D3 call. And this, because of the model of cascading style sheets, the cascading means that the most specific one is the one that would be used. So in this case, if I had it on a particular element with a style tag, then that would override anything that's in the general CSS style sheet. So that example is on NL West Color 4, and you can do it and you can comment out the various components and to see how the colors work. Okay, so last but not least is data labels. So you see I have 5 bars here and they map to my data, but unfortunately, it doesn't really mean anything yet. A user can look at that and they have no way, there's no context as to exactly what that means. So I've got to label them in some way. But unfortunately, because I made all of the X positions be 0, I didn't leave any room for labels. So before I can put labels on, I first need to scooch them over a little bit and provide some room for labels. So the way I'm going to do that is I'm going to create margins inside of my SVG. And the typical way that that's done, again, this is a convention, the margin convention that's very common in the D3 community, is to create a variable that's of a dictionary type and essentially define the 4 values, top, bottom, left, and right, done like that. Now I could just have created one variable and assigned a number to it and made all the margins the same size, or I could have used 4 different variables and named them all separately. But again, the way that I did it here is the way that you'll find it commonly done. And so then I can say, okay, I have a left margin, I'm going to leave 160 pixels so I can put a label, plus I'm going to leave a little bit of space on the right. So what that means is now my space that I have to work with for the bars is now less than it was before. Because before I had 800 pixels, but now because I've gobbled up some of that, I'm down to only 490 pixels instead. Did I do the math right? I think it's actually 590 pixels as I'm thinking about this here. Anyway, but it doesn't matter because in my X scale calculation, I can provide these values right here, and then all the adjustment will be handled for me. So, you know, it will recalculate all of these and make the bars relatively fit in whatever space I've defined based on the subtraction. In this case, the width of the SVG minus the margin space I wanted to do on the left minus the margin space I want to do on the right. When I do that, then my bars have all shrunk. Now you may notice that my bars also moved over. They're no longer along the left side. And I didn't talk about how I accomplished that, but there's one more attribute that I've introduced to you down here below, and that's transform. So I'm going to talk about that on the next slide here. And this is a little bit of a tricky thing to wrap your arms around at first. But what you're effectively doing is you're saying create all of the bars with an X value of 0 and then move them all. So this translate moves the origin of the grid from 0, 0 to, in this case, 160 and 100, only for purposes of each one of these bars. So it allowed me a nice clean way to move them and leave space for the labels. I know there's a lot to wrap your arms around on this one, but I assure you that it's very common. So it's a construct that you'll really want to become familiar with because you'll see it a lot when you start looking at the examples. But basically the 2 things that I did here, the top one and the bottom one, are essentially doing the same thing. The one on top has it hard coded and the one on the bottom is referencing the variables that I created. Okay, and then the last thing is to talk about iterable data, because if I'm going to put the labels in, I don't actually have the labels in my data set anywhere, because all I had was a data set that was a set of numbers. So I've listed the data a couple of different ways now. On the lower left, as an array of nested values with the team names and the number of wins, and on the right hand side as a dictionary with labels and how many wins they had. But in either case, the data set is still an iterable array. Notice there's square brackets around each one of them. And it's actually much more common to have data sets like you see on the bottom than the simple example that I had when we showed. So how do we reference that if we have a more complicated data set? Because before it was just an array with 5 numbers on it, but now it's going to pass a nested array in each one. So I have to change my function D, because the function D is still going to return the entire thing that was iterated. So if I want only one piece of the iteration, my function D now has to change in what I'm going to call. So in this particular example, if you notice the width, I'm referencing D and then in square brackets 1, which is the second element of the nested array, right? So the team name is the first element, and that would be D0, and then the number value, a numeric value, is the second one of those. That's what's getting passed to X scale. If, on the other hand, I had defined it as a dictionary like this, then I can use dot notation to say, well, I want to see the wins value from the dictionary that was returned by function D. Okay, so then if I want to put the labels on themselves, notice now I'm doing this the same structure we saw when we created the rectangles, a select all, then the data and the data set, and then enter, and then append text. And then here you see the new dot text, which says what is the actual text string that I'd like SVG to render. Then I'm positioning it at with an X value of -8. Okay, the Y's are still remaining the same. And then I'm still transforming it the same way I transformed the rectangles. So when I do that, I ended up with almost what I wanted. The issue that I'm facing here is that the position that I actually specified for the X and Y is I've got shown by the yellow dot here. And so that's basically the bottom of the text. So all I really need to do is to move it down by the value of half of the height of the bars in order to center it. So when I do that, you see I'm using now margin top plus 30 in my transform, and then I get the values where I wanted them. I've also now applied additional CSS elements to use a prettier font, and that's essentially the bar chart that I wanted to make and try to squeeze into this hour right here. And that's the one that you'll see at number 5.labels. So as you go away, I encourage you to go back to my website and take the one that I had, and then you can see this more elaborate example here that has essentially the same data set, but it's animated because I have more than 1 year worth of data in it. And so you can kind of get an idea to see how to transform it, and also how I made each one of the elements a different color, and how I put a label on the top of it. And I had some of these built in here at one point, but I realized that there was no way I was ever going to get it done in an hour, so I had to cut back. So with that, I believe that's all that I had for you today. Just to wrap up here, this is all the things that we covered, and then there's kind of my contact information. I'll put the slide deck into Dropbox as well, so that you can have the slides if you'd like. I'll have it both as a PowerPoint and a PDF. Madeline, I know we have only a couple of minutes still. Were there any questions that popped up?
I'm not seeing any right this second, but we can give it a minute or so and see if any arrive. As a reminder,
I know that
if you have a question,
there's a delay in here. So
yeah. If you do have a question for Dan, you can always put it on in the Slido chat that's on the right-hand side of your screen. I'll be able to see them and can relay them back to Dan and he can answer your questions. So feel free to put them in there. Or if you're hanging out in the Slack room for room 5 in the channel there, I can also see questions that are put on there. So we'll wait for a minute or two and see if anything comes in. Okay, we've got a first question coming in from Lisa. And she is asking any final tips on D3 learning resources?
Um, yeah, so first of all, I think all of the examples that showed up are a great resource, because you can actually look at the code. Although if you're a novice like me and I didn't have super good JavaScript skills, a lot of it was over my head, and so I had to spend a lot of time trying to take it apart. Another resource that I found that was really good is a guy named he's on YouTube, and it's Kelleher is his last name. I'm trying to remember his first name at the moment. But he has a whole bunch of slides, and a whole bunch of videos, and most of them are 45 minutes to an hour long. So he really dives into each of the topics. Kieran Kelleher is his name, Curran, and then last name Kelleher. Does a really good job of explaining these things. So if you're into watching YouTube videos for learning, I'd recommend those as well.
Any other additional questions for Dan that we can answer before the session wraps up?
Well, I'll just say, because I know there's a delay, I'll hang out over in the Slack channel for a couple of more minutes after we cut this off. But thank you to everybody for attending. I appreciated your attention. I know it's late in the day and it's been a lot of sessions today. So thank you very much for tuning in, and good luck. And I'd love to hear any success stories or any questions that you may have.